Okay, so welcome back everyone. In this exciting lesson, we're going to discuss about the rendering process, which is really going to be very important. And many a times I have, I've been approached that there should be some important areas so that the students can also deal with the rendering process, especially handling the fluids or the volumetric data or the FX elements. All right, so here we can see that we are at frame number 35, and still I'm using a little bit low resolution, so just to make the scene pretty much fast for you to understand. This is These are the fluids that are at 100 resolutions. Okay, so now the problem is that how to begin with the rendering process. Since this fluid is a volumetric data, all right, this is not a surface based or the mesh data, so we need to have certain rules for that. Again, I'm gonna rely upon myself with the mental ray render for that, but I also gonna encourage you to go for the Arnold rendering. This is really gonna be fast for dealing with the volumetric data. Okay, so just to make this very simple and quite understandable to all of you, I'm just using some rendering layers here. You can see by the name called the dry underscore eyes underscore layer shadows. Okay, so this is the dedicated rendering layer system that I've been using to render out the volumetric fluids. Okay, and the scene elements, that is the high polygon, occult cup, and the base floor and the surroundings, will not going to be calculated inside this rendering layer process. Okay, so first of all, I would like to show you with the settings that I'm using in the scene. So let me just go inside the render layer setups. Here you can see that. And under the quality tab, I would like to go for the sampling mode, which is the legacy sampling mode. And I guess with my 2014 and the 15, you're going to have something called the unified sampling. This quite efficient. Unified sampling is really going to be very powerful method for rendering the surface data. But I think so that when I was rendering with the fluids, when I was comparing that thing with legacy, the unified sampling process was taking quite a bit time to sample out the things, and there was still going to be some little jittering inside the fluids. So I guess for me, the legacy sample mode is really going to be best for this course. Okay, and for that, I've also raised the max sample level to 1, because while rendering with the fluids, if you're gonna take that thing to the 2, obviously it will gonna add up to the rendering time. But you may also can do, since there are certain reasons for that I'm gonna tell you later for that. uh, One of the reason is that because we also do have to deal with the polygon data, since like in this case you can see I have the fluids with me, but I have also got the low polygon proxy geometry also. So whenever the fluid will gonna start coming over this surface, as here you can see that there are some anti-aliasing issues that will again gonna come inside the rendering also. So for that, we need to have the max sample level to 1 or 2. Okay, otherwise you obviously gonna have some problems. Okay. Okay, that was one thing. Now, for the second thing, again, you may also could dip down the anti-aliasing contrast, let's say 0.050, which is again going to help you in dealing the best anti-aliasing things. And again, I've switched that thing to the Michelle with jitter and sample locks with filter size at the thing to 4:4. Okay, that's fine. The ray tracing is obviously we have to use, since we have to calculate the shadows. And now the important question arises on the shadow, which is really going to be important for me. Let's say I'm going to show you with some renders that I've got uh, for this fluids. But I guess before I take you to the render, let's just talk about the important lighting section of the fluids which we have to go. So under the lighting section of the fluid container tab, you can see that I've switched on the self shadow. We have tweaked certain values in the previous lesson also, but the most important thing to understand in this course is that the shadow opacity is really gonna important. If you're gonna use the lesser value of the shadow opacity, it will gonna make the fluid have obviously the less shadows entering inside the fluids. So we have discussed all these things with you, but now the important thing is that we have to check off this option, something called the real lights. So by checking this option off, what will gonna mean? It'll simply gonna mean is that the fluid has its own rendering algorithm to calculate the light, but it also need physical light inside our scene to calculate the shadow parts. so that the fluids can cast out the shadows on the other geometry elements. This whole section is dealing only to the fluids, doesn't have to take care anything on the polygonal or the NURBS object. All right. So the self shadow itself reveals the fact that the fluids are casting out the shadows inside their own. But to cast the shadow onto the object, you're going to need to have another light. But provided the real light should be set that thing to off. If you switch them on, then all those lighting that are inside the fluids will going to contribute toward the rendering of the fluids. And frankly speaking, this is really going to push your rendering times to certainly 10x to 15x values, which I never going to recommend you. Okay, so let me just show you with up that the directional light I'm using inside here with the light type. You're gonna have three lights called diagonal, direction, and the point. But in this case, I'm using the directional with light color. Set that thing to white because I just prefer to have the lighting data to be really very white because I have the chance to tweak certain colors and midtone values inside the composting packages also. So for me, this is really gonna be okay. The ambient brightness I've already explained. We're gonna add some more lighting from the environment. And as such, the directional light is concerned, 0.5 from X, 0.65 from the Y, and 0.5 for the Z. I have, kept these values. And I think so. This is the render that I've got while using these settings. Let me just, maximize them. So that was the render of the fluids. This was the first render. And this was the third render, which, I just a little bit changed the value of the Y-axis, followed by this again from the top view. And I think so this was with the high polygon geometry, set that thing to the on, and this was again the same render with a different camera view. All right, so these are the changes that I've got while the rendering process was taking place. But again, I would like to draw your attention towards this thing. The main setting which we have to do while taking care of the rendering subject is that your light, which is in our case is the point light. And what are the attributes of the point light? Let me just open that up in the attribute editor. So here you can see that we have used the intensity of 1000 with a quadratic decay, which is the naturalistic decay process. Since the light passes, it travels more distance, the intensity will going to get 1 by square of the distance to get the light start get fading. And of course, while dealing with the volumetric data, we need to have only and only the rate as shadow. The depth map will not going to play any role inside here. And we just do have very simple settings in the light radius that we're going to create some softness in the light with shadow rays that we're going to remove the jitterings of the radius shadows. And the ray depth limit, I have set that thing to 3, but I don't think so we're going to need them more than 1 because we don't want the fluids to come appear inside the reflections or the refractions and again to show these shadows. Okay, but again, as the term shadow is coming, one thing is consistently striking in my mind is that the usage of the shadow along with the exact value. And what exactly the statement means, well, you need to go to the rendering settings once again, and here you can see that I have the important option that is something called, we just switched off all of them to concentrate properly. All right, so under the quality tab of the Mendelray, we do have something called the shadows. By default, the simple method is set for the ray trace shadows. Okay, so what we're going to do is that, let me just render out the fluids for you. Okay, so let's have a camera shot. Just pick up only a smaller section and just put that thing to render. All right, that's fine. So here you can see that we have to got the render, but now the problem is that while using with the simple ray trace shadows, you can see that there isn't such shadows coming onto the surface, which is really going to be a problem for us. So here you can see that clearly there isn't any shadows appearing inside here. So the solution for that is, let me just gonna save that scene for you and open up the render view, the render settings actually. Now we're gonna take the shadow method from simple to the segments and now just have some more difference. Okay, so let's just save that up and re-render the process. So now see that it's quite apparent that with the use of the shadow type set that to the segment, we have started, getting the shadows of the fluids. So before it wasn't set that thing to the segment or to the sorted or simple, the fluids will not going to cast out the shadows. All right. One more important thing is that for the to support the shadow, I have used the a shader which is called the use background, and I have applied that shader on the low resolution proxy object as well as the polygon plane. Okay, so and the settings are really going to be simple. We are not utilizing the reflectivity since we don't want to calculate the reflection, so I've just put that thing to the 0. The shadow mask, I've dedicatedly put that thing to 0.85 because I just don't want to have completely dark shadows. Although I do have the chances and uh, the facility to tweak down the value inside the compositions. All right, so this really not going to be a problem for us. And with that, I guess we're done with the rendering setup and the lighting setup of the fluids. Moving again to the next lesson to understand the rendering of our scene. All right.